In this video, we're going to go over what it means to be isoelectronic. This is an independent study. It's an enrichment portion of the course. You'll see it's not very difficult. We already sort of covered it in the previous video, but now we're just giving it a definition. Iso means the same. So isoelectronic means when two substances have the same number of electrons. So let's take a look at sodium. Sodium, if you were to draw out its Lewis structure, or its Rutherford diagram, has 11 protons and 23 minus 11, 12 neutrons, and it would have 11 electrons. So 2, 8 on the second, and then 1 on the last. Now, when sodium forms an ion, it would have 11 protons still, 12 neutrons still, but now it loses its electron in the outer shell. And looks like this with its bracket over here with 1 plus. But now it lost an electron, so now it has 10 electrons. So sodium was a metal, and so sodium over here lost 1 electron and became like neon, has 10 electrons. Just to show you neon has, let's just take a look here, periodic table, so 20, 10, okay, so 10 protons, 10 neutrons, and then 10 electrons. But now it doesn't have a charge because it has 10 electrons, 10 protons, they cancel out. It's not going to lose or gain electrons since it's already happy. But the point is that Na plus is isoelectronic to neon. So it became like the noble gas that came before it by losing an electron. So metals lose electrons and become like the noble gas just before them in the periodic table. And so we say they're isoelectronic to them. So the sodium ion is isoelectronic, same number of electrons, to neon. And I demonstrated that here, 10 electrons, 10 electrons. Whereas nonmetals, they become like the noble gas that comes after them. So for example, oxygen is going to gain 2 electrons to become like neon. It's not going to go backwards and become like helium. Lithium could do that, it would lose and become like helium. But oxygen has 6 valence electrons, it's going to gain 2 to get to neon, essentially. It's not going to become neon, it's going to look like it in terms of electrons. So oxygen has 8 protons, 8 neutrons, 8 electrons normally. So 2 on the first, 6 on the last shell. When it forms an ion, it'll still have 8 protons, still have 8 neutrons, but it's going to gain 2 electrons to finish the last shell. Right here and here. And so we're going to have a charge of 2 minus. So now oxygen has 10 electrons, this oxygen ion. This one had 8 electrons. And what else has 10 electrons? Well, neon does. So neon, like we drew above, 10 protons, 10 neutrons, 10 electrons. Neon and the oxide ion, so O2 minus, is isoelectronic to neon, same number of electrons. So let's go up here to our table we saw earlier. Here we had aluminum 3 plus, and it was I believe 27 and 13. And so we want to find out what these are isoelectronic to. So bromide is a nonmetal. Bromide is going to gain an electron and become like krypton. It's going to have 35 electrons. It gains 1 more because it's in group 17, gains 1, becomes like krypton. So we could say the bromide ion is isoelectronic with krypton. But if you look at aluminum, aluminum is a metal. So it has 3 valence electrons and wants to lose 3. It had 13 electrons, it'll lose 3, and then have 10 electrons like neon. So aluminum goes back and becomes like neon electron-wise. So aluminum would be isoelectronic with neon. So isoelectronic just means that they have the same electron layout. So ions can be isoelectronic to noble gases when they form. And usually the metals become like the noble gas just before them because they lose, and non-metals become like the noble gases that come right after them in the periodic table because they gain. And that's all isoelectronic means.